A supermassive black hole devours the equivalent of one Earth every second, a staggering phenomenon that compels attention. This marks the first-ever image of a black hole in space, highlighting these cosmic giants that consume everything in their path, including light itself. Black holes form from the remnants of massive stars, possessing gravitational forces so intense that they distort space and time, trapping everything, even time itself, within their grasp. A recent discovery by the James Webb Space Telescope challenges the fundamental principles of our understanding. How does this discovery cast doubt on our long-held beliefs about galaxy formation? Does this cosmic anomaly pose a threat to Earth? Join us as we delve into how the James Webb Telescope has detected a massive dormant black hole near our solar system. Black holes are elusive, even though Einstein's theory of relativity predicted their existence, finding one proved challenging. Unlike stars, black holes do not emit light, making their size and speed the only measurable properties. We now have photographic evidence of black holes, confirming their existence, though definitive proof was elusive for a long time. The first black hole, Cygnus X-1, was discovered in 1964, but even prominent scientists like Stephen Hawking and Kip Thorne didn't agree on its nature until over 30 years later. Hawking, who devoted much of his career to studying black holes, was confident in their existence but remained uncertain about our ability to locate one. After years of accumulating evidence, Hawking conceded the bet in 1990, acknowledging Cygnus X-1 as a black hole. The discovery involved launching 2 Geiger counters into space, detecting a signal from a system 7,200 light-years away, where a blue supergiant star orbited another large object emitting X-rays, a sign it could be a black hole. Cygnus X-1 has since revealed more surprises, including being 21 times the mass of the Sun, making it the largest stellar mass black hole discovered without gravitational waves. This challenges existing assumptions about black hole formation, as such a massive black hole implies reduced mass loss from massive stars over their lifetimes. Cygnus X-1 also holds the record for the fastest rotational velocity, nearing the speed of light, further defying standard models of black hole evolution. While conclusive evidence of black holes is relatively recent, it's clear they are scattered throughout the universe. Scientists have now discovered a dormant giant less than 2,000 light-years from Earth, Gaia BH3, the Milky Way's largest stellar black hole, with a mass 33 times that of our Sun. Despite being the second closest black hole to Earth, Gaia BH3 had remained undetected until recently. Found in the constellation Aquila, it was discovered through a peculiar wobble in a star's trajectory, suggesting it was ensnared by a massive black hole. Observations confirmed Gaia BH3's mass and its star's 11.6-year orbit around it. This discovery of a hidden high-mass black hole was unexpected, adding to our understanding of stellar black holes, which typically have around 10 solar masses. Gaia BH3, however, is dwarfed by supermassive black holes like Sagittarius A** in our galaxy center, which is 4 million times the Sun's mass. The discovery of Gaia BH3 is crucial as it provides new insights into how stellar black holes form from the collapse of metal-poor stars, leaving more material to create massive black holes. Until Gaia BH3, scientists lacked examples to support this theory. Meanwhile, the James Webb Space Telescope has uncovered a supermassive black hole in the early universe, around 700 million years after the Big Bang. This black hole, about 40 million times the Sun's mass, is rapidly consuming surrounding dust and gas, located 12.9 billion light-years away. Its redshifted light suggests a thick veil of gas and dust around it. Supermassive black holes, often linked with quasars, create immense gravitational forces, heating surrounding matter and causing it to glow. These cosmic titans also eject material through jets, which can travel at near-light speed, emitting bright electromagnetic radiation. The JWST's data revealed this black hole as a small, star-forming galaxy, distinct from other quasars due to its size and behavior. Even with JWST's infrared capabilities, this quasar wouldn't have been visible without gravitational lensing, predicted by Einstein in 1915. This effect, caused by the warping of spacetime by massive objects, allowed the JWST to magnify distant galaxies, revealing the quasar as 3 red spots. This discovery adds to evidence that supermassive black holes were common in the early universe, raising questions about the growth of both black holes and their host galaxies. The relationship between them remains largely unknown, presenting an astronomical twist on the classic chicken or the egg dilemma: did the galaxy or the black hole come first? Researchers may have also found evidence linking microquasars, smaller versions of quasars that feed on nearby stars, to the production of high-energy cosmic rays that reach Earth. These cosmic rays, first discovered in 1912, have energies far exceeding those produced by Earth's particle accelerators. Microquasars like SS433, the first discovered in 1975, eject star matter through jets, creating shock fronts that accelerate particles to extreme energies, producing gamma rays. This suggests microquasars are significant sources of cosmic rays, alongside supernovae. SS433's jets, which collide with surrounding matter, produce these high-energy particles, challenging our understanding of cosmic particle accelerators. These findings underscore the complexity and mystery of black holes and their role in the universe, with each discovery offering new insights and raising more questions about the cosmos. A supermassive black hole has the capacity to consume the equivalent of an entire Earth every second, a staggering and mesmerizing phenomenon. The first ever captured image of a black hole reveals these cosmic behemoths that devour everything in their vicinity, including light itself. Born from the remnants of colossal stars, black holes possess gravitational forces so intense that they warp space and time, trapping everything, including time itself, within their grasp. Now, a groundbreaking discovery by the James Webb Space Telescope challenges the core of our understanding. How does this new evidence cast doubt on the long-held beliefs about galaxy formation? Could this cosmic anomaly pose a threat to Earth? Let's delve into how the James Webb Telescope uncovered a massive dormant black hole near our solar system. Black holes are notoriously elusive. Detecting the first one was an immense challenge, even though Einstein's theory of relativity suggested they were abundant. Unlike stars, black holes emit no light, leaving their size and spin as the only measurable characteristics. The existence of black holes was once purely theoretical until photographic evidence confirmed their reality. However, it took decades for scientists to obtain conclusive proof. The first black hole, Cygnus X-1, was discovered in 1964, but it wasn't until over 30 years later that Stephen Hawking and Kip Thorne, two leading black hole experts, fully agreed on its existence. Despite Hawking's certainty that black holes existed, having devoted much of his career to their study, the question of whether one could actually be detected lingered. This uncertainty led Hawking to hedge his bets until sufficient evidence accumulated by 1990, compelling him to concede the wager he had placed years earlier. The discovery of Cygnus X-1 was initially made by instruments aboard a suborbital rocket, which detected signals from a system 7,200 light-years away, featuring a blue supergiant star orbiting a massive, X-ray-emitting object, presumed to be a black hole. Over the years, Cygnus X-1 has continued to surprise scientists. Recent research shows that this black hole is 21 times the mass of our Sun, making it the largest stellar mass black hole discovered without the aid of gravitational waves. This finding challenges the traditional understanding of black hole formation, as such a massive black hole suggests a much lower rate of mass loss from its progenitor star than previously believed. Furthermore, Cygnus X-1 has the fastest rotational velocity ever recorded for a black hole, nearing the speed of light, a trait that defies established models of black hole evolution. Even as astronomers continue to unravel the mysteries of Cygnus X-1, countless other black holes across the universe remain unexplored, each holding potential surprises. Less than 2,000 light-years from Earth, scientists have identified another colossal black hole, Gaia BH3, dormant but with a mass 33 times that of our Sun located in the constellation Aquila. This black hole was discovered by the European Space Agency's Gaia mission, which maps our galaxy in 3 dimensions. Gaia BH3's discovery was unexpected, as its dormant state made it nearly invisible in sky surveys. However, its presence was revealed through the peculiar wobble of a nearby star, orbiting the black hole every 11.6 years. Gaia BH3 stands as the second closest known black hole to Earth, providing astronomers with crucial insights into the formation of stellar mass black holes from metal-poor stars, which lose mass more slowly over time. Meanwhile, the James Webb Space Telescope has revealed an extraordinary supermassive black hole, enshrouded in a thick veil of gas and dust, situated in the early universe around 12.9 billion light-years away. This black hole, with a mass 40 million times that of the Sun, was discovered through its intense redshifted light, a consequence of the universe's expansion. The surrounding gas and dust are rapidly being consumed by the black hole, which appears as a bright red dot in JWST's data, suggesting a quasar-like object. Quasars are powered by supermassive black holes that generate immense amounts of energy as they consume surrounding matter, forming accretion disks that emit powerful radiation and relativistic jets. This new discovery adds to the growing evidence that the early universe was populated with supermassive black holes, far more common than previously thought. The interaction between these black holes and their host galaxies remains a mystery, much like the classic question of which came first, the galaxy or the black hole. Yet, as we uncover more about these cosmic giants, we begin to understand the forces that shaped the early universe. Researchers also believe they have found evidence linking microquasars, smaller black holes that consume stars in binary systems, with the high-energy cosmic rays that bombard Earth. These microquasars, though milder than their larger quasar counterparts, can still accelerate particles to incredible energies, producing gamma rays detectable by telescopes like the High-Energy Stereoscopic System, HESS. The Milky Way's most powerful microquasar, SS433, was the first to be discovered and remains a subject of intense study. Its jets, traveling at near-light speeds, generate shock fronts that accelerate particles to the extreme energies observed in cosmic rays, offering a potential explanation for these mysterious high-energy phenomena. SS433, first identified in 1975, gained notoriety after appearing in a science fiction catalog, and has since become a cornerstone in the study of microquasars and cosmic rays. As we continue to probe the depths of the universe with advanced telescopes and new technology, the secrets of black holes, whether supermassive, stellar, or microquasars, are gradually coming to light, revealing the complex and dynamic forces at work in the cosmos. Each discovery brings us closer to understanding the origins and evolution of the universe, as well as the role these enigmatic objects play in shaping the galaxies and stars around them.